forgot to record the first half of this.
That's all right.
I just turned it on
I
now.
wrote it all down.
Okay, good. So we've got cosine of x plus 5 pi over 4 plus cosine of x minus 5 pi over 4 all equals 1. Which is the sum and difference. I'm trying to think if there's any other way I would do this. No, there isn't.
Okay.
So let's translate this. I'm going to write very small because obviously this is going to translate into 4 terms and this has 4 more terms. So what's the first part of this?
It'll be the cosine one. So can you do it when there's just a variable x?
Yes, you can.
Okay.
So what is it?
Oh, cosine of x, cosine of 5 pi over 4, minus sine of x, sine of 5 pi over 4.
That's that part. That's this part here. Now let's do the next part. I'm going to add these two things together. What's this part over here?
Let's see, it'll be cosine of x, cosine of negative 5 pi over 4.
No, well, we're going to use the 5 pi over 4.
But not the negative?
No, because this is going to be the difference formula. In other words, there's a formula for the sum and there's a formula for the difference. So this one will be a plus sign.
So then it'll be minus. Yeah, plus.
Plus, because the first one was minus because it was opposite this plus.
Yeah.
So this one needs to be plus to be opposite that minus. So now we have sine of x, sine of 5 pi over 4. And if we add those together, you'll notice that this part crosses out with that part.
Oh.
They're the same thing. One is minus, one is plus. So now we have this plus this. Okay, well we can solve that. That is 2 of those. 2 cosine x, cosine 5 pi over 4. And the equation is that it's equal to 1. So now we're well on our way.
Yes.
What's the cosine of 5 pi over 4? That's a number.
Over 4 would be 100 or 215 degrees?
Remember, we're taking the cosine of an angle and we're getting a number. So the answer is not an angle.
Oh, okay. So
What quadrant are we in?
it wouldn't. The third.
Okay. What's its equivalent first quadrant angle?
45.
Okay. So what's its third quadrant? Answer.
So it's not an angle though.
No, it's a number based on.
Oh, okay. I know what it. Okay, yeah, I got it. It's would it be root 3 over 2?
No, it's 45 degrees, right?
Oh, so root 2 over 2.
There you go. So this is the 2 over 2. So I can substitute a number for this expression.
Yes.
Now I've got root 2 cosine x equals 1. You see that? In other words, this 2...
Oh, yeah, because you can just take
no, hold on. oh yeah, this is not cosine of square root of 2 over 2. This is a number that goes in front of this number. So the 2's do cancel. And then I'm left with square root of 2 cosine x equals 1. So cosine x equals...
cosine x would equal 1 over root 2.
Okay, or if I rationalize that...
root 2 over 2.
Okay, so x is equal to what?
X would be equal to 45 degrees.
And in the interval 0 to 2 pi,
degrees.
What's the other one?
135. 135.
Cosine's negative in the second. It's also negative in the third.
Oh, so fourth quadrant. So then it would be 315 degrees.
Right. Okay. And that's pi over 4, and this is 7 pi over 4. Now, we kind of have to go back and check both of those solutions. Whenever you come up with two solutions, it's a good idea to check it.
Yeah.
So what's the cosine? We're going to check pi over 4 first. So we've got pi over 4 plus 5 pi over 4. That's 6 pi over 4. That's 3 pi over 2. So that's the first part. Plus cosine of pi over 4 minus 5 pi over 4 is the cosine of pi.
Negative.
Minus pi.
Yeah, negative pi, that's what I meant.
Okay. So what's the cosine of 3 pi over 2?
0.
Here's our cosine curve. 3 pi over 2 is 0. Very good. Sorry. And what's the cosine of minus pi?
It would still be 1, right?
Right. No, negative 1.
Negative 1. That's
Hold on. No, you're right. Just a second. I'm confusing myself here. So the cosine of minus pi is the same as the cosine of pi, which is negative 1. And that doesn't work. We have 0 plus negative 1 is not equal to 1.
So then pi over 4 isn't an answer.
Yeah, unless I've made a mistake in my math here. Let's check 7 pi over 4.
I don't think you did.
Let's check 7 pi over 4. See if that works. So 7 pi over 4 plus 5 pi over 4 is 12 pi over 4. So what's the cosine of 3 pi?
It would be 1.
Negative 1.
Negative 1.
Right?
Yeah.
In other words, 3 pi is out here. This is 2 pi right here. So if we take away a 2 pi, it's the same as the cosine of pi, and that's negative 1 right there. Okay, so when I plug in 7/4, 7 pi over 4, we get negative 1 for this first part.
And then
This is going to be hard to make this work because this is going to have to be 2, and that can't be. You see why?
That's true, yeah.
That's going to have to be 2 for the whole thing to be 1. So I've made a mistake here somewhere. Let's see. What did we do?
Well, the answer could be that there's no solution.
It could be. It could be that there is no solution, yeah. So we'll assume that either that's the correct answer or I've made a mistake. Can't see my mistake right offhand. then when I got one of these and I add another one, I got two of them. So this should be right. Huh. Well, I don't know. I guess rather than rehashing that problem out, I'm sure we did it correctly. But I could easily have made a mistake in my math. Let's see, that's cosine, cosine minus sine, sine. And then we're adding to that cosine, cosine plus sine, sine. So these two terms disappear, and we're left with just these two terms. 2 cosine x, cosine of 5 pi over 4. I see what I did. I didn't put my negative sign in there. Cosine of 5 pi over 4 is negative root 2 over 2. So now it's a negative root 2 cosine of x. So this is negative. So that changes my answers. Not 45 degrees anymore. It is 135 degrees, second quadrant, and 225 degrees, third quadrant.
Yeah.
And that is 3 pi over 4 and 5 pi over 4. And if we substitute both of those back in, it'll work. Notice that just substituting the 3 pi over 4, we get the cosine of 2 pi, which is 1. And then the cosine of minus pi over 2 is 0, so we have 1 equals 1. Hold it. 3 pi over 4 gives us 0 here. 3 pi over 4 here gives us minus 2 pi over 4 minus pi over 2. Excuse me, this is 1. The cosine of 2 pi is 1. The cosine of pi over 2 is 0, so we have 1 plus 0 equals 1. So 3 pi over 4 works. And 5 pi over 4 is going to work also, because this will be 1 here, and this will be 0 when we substitute 5 pi over 4 for x. So both of those solutions work.
Okay.
It's a bear when you make a mistake with a sign.
Yeah.
It really is. I mean, it can drive you nuts. And it's not hard to make a little mistake like that. It's pretty easy. When you have problems that have 5 or 6 steps to them, it's real easy to make a mistake. So my only advice is to be very, very diligent when you're doing a 5-step problem. Or for that matter, a 3 or a 4-step problem. You have to be just as perfect. If you have a 9-step problem and you make one mistake, you're missing the problem. So the more steps there are, the more perfect you have to be. Okay, you got anything else you want to go over? We got 20 minutes if you want.
Yeah. I'm just going to have to read it aloud to you, but that should be okay.
That's fine, yeah.
Get to it. Alright.
How about if I told you to find me the sine of 165 degrees?
Then I could do 30. Yeah, I could do 30 plus 135.
Okay, so we're going to make it the sine of 30 plus 135. So that's going to be equal to what?
Sine of 30, cosine of 135. plus sine of 135 cosine 30.
What's sine of 30?
Yeah, which is a half, and then cosine of 135 is root 2 over 2.
Negative.
Negative root 2 over 2, yeah.
Second quadrant. What's sine of 135?
Root 2 over 2.
Positive. Cosine of 30?
Would be 1/2.
No, that's the sine of 30.
Oh, that's the sine of 30. It would be root 3 over 2.
Okay. And now we have minus root 2 over 4. I'm multiplying this times this. Plus root 6 over 4. So the answer, I could say, is 1/4 root 6 minus root 2.
Yes.
That's equal to the sine of 165 degrees.
Huh. All right.
Okay? The trick is usually to figure out how to break that out. And there's multiple ways. You could do it 30 and 135. You could do it 210 and 45. I could have done it 210 minus 45. Right? That's also 165.
Yeah.
And I know all of these. I know what the angles for 210 are, or I know what the trig functions for 210 are. So there's lots of ways to do this, and usually you can do it by adding or subtracting. It's just you have to be a little creative sometimes, and even more creative when they do something like this. Break that up for me.
That could be 12.
Do this two ways. You can convert this to degrees and then break it up, which is probably more comfortable for most people.
Yeah, for me it is.
And you could always turn it back in. But I know that that's 3 pi over 4 plus 3 pi over 12 plus 4 pi over 12. And this is pi over 4, and this is pi over 3. So it's pi over 4 plus pi over 3.
Yep.
But like I said, you can break it into degrees, and then it would become 45 and 30, so this must be 75 degrees.
Yeah.
All right. You got one or a few that you want to read to me?
Sure. Let me find one real quick. I'll go to the next thing. How would you do... it says that you are supposed to use power reducing formulas to rewrite the expression. If I give you an expression, can you do that?
We can try. I'm not up on my power reducing formulas. Not everybody gets those. I'd have to look them up. Or you can give them to me, but let's try it.
Sine to the 6th of x.
Just that?
Yeah.
Okay. Well, I don't know how to use the power reducing formulas, but that's sine squared times sine squared times sine squared. Each sine squared is 1 minus cosine squared. I'm not sure what... Do you have an answer for that one? I'm not sure why this is any better than sine squared times sine squared times sine squared. They want you to use the power reducing formulas. Let me get my book. Maybe I can see how that works. I have actually 2 books. One of them does have that. That's in the trig section, it has the power reducing formulas. Let me look it up. Do you do product to sum and sum to product also?
I don't think so.
No, I'm not sure this does have the power reducing formula.
Mine has it in here.
Yours has it? Let me just look up in my index. Maybe it can take me to the page. Power reducing formula.
It has a very different answer. Not what I would have expected.
What does your power reducing formula say?
Alright.
What's the formula for it? It must be sine to the m of x.
Sine squared in my book.
Okay. Equal.
And then equals 1 minus cosine of 2u over 2, or 2x over 2.
Ah. That's actually the double angle formula. In other words, when we, have you had double angle formula yet?
No.
Okay. You'll get the double angle formula, and the double angle formula is 1 minus 2 sine squared of x. And they also call it the power reducing formula because that's the same thing. In other words, if I were to solve this for sine squared of x, I would get this. And it allows me to reduce these powers such that now I can take my sine to the 6th of x, which is equal to sine squared times sine squared times sine squared. And each sine squared is that. So it's actually this to the 3rd.
Oh.
And I don't know if they want you to multiply it out or not. In other words, whether they want you to expand it completely. They probably do. But that, whatever that equals. We probably don't have time to come up with an answer. But that's what. Notice that then we would have reduced at least from a power of 6 to a power of cubed. Because when we expand this out, we are going to have a cosine cubed of 2x.
Yeah, the answer it liked was 1 over 32 times, in parentheses, 10 minus 15 cosine of 2x plus 6 cosine of 4x minus cosine of 6x.
Okay. In other words, what they're doing is they're expanding this out based on that. And then they're taking each one and reducing it more. There's also a power reduction formula that says this. That's what cosine squared is equal to.
Yeah.
Okay, so once we end up with a cosine cubed, we can turn it into a cosine squared times a cosine, and then we can turn the cosine squared into this. So eventually we're going to have everything down to a single power. There won't be any squares, cubes, or anything left. We will have cosines of multiple angles, and that's why you have a 4x and a 6x and all of that. But the secret to this problem is to expand that out and then use this to convert any cosine squareds that you have or cosine cubes that you have.
Yeah.
You know what I mean?
Yeah.
Okay. It'd be easier if they'd have made this to the 4th, because then we just have to square it. Should we go through it? If you can do it for the 4th, you can do it for the square. I mean, for the 6th. In other words, if I said, what's the sine 4th of x, That's sine squared times sine squared, which is this squared. Let's go ahead and square that. And we get, all right, let's see, this is 1, let's just square the top and square the bottom. Squaring the top gives me 1 minus 2 cosine 2x plus cosine squared of 2x all over 4. You with me?
Mm-hmm.
Now we're going to apply the cosine squared. If I can find my cursor here. So now we got 1 minus 2 cosine of 2x plus, well, what's that? That is 1 plus cosine of double this angle, so that's 4x over 2 all over 4. So that's what sine square, that's what sine to the 4th of x is equal to. Now, I could do some algebraic simplification here, but you'll see that we end up with no exponentials anymore, and we do have a cosine 2x and we have a cosine of 4x, which are different, but we've reduced it from cosine squareds to cosine of multiple angles. And that's key when you're doing calculus. In other words, if I want to integrate the sine of 4th of x, that's awful hard to do. But I can integrate this. Now, I know you don't know what integration is yet, but that's why the power reduction formulas are so important, is because it allows you to do trig or calculus on trig functions, where it's really, really hard to take the integral of that.
Huh.
But it's easy to take the integral as long as there's no exponents.
All right.
All right. Well, let's call it a session. And hopefully that's been helpful to you.
Definitely.
Okay. All right, Max. Let's see. I don't think you have any. Next week you're on spring break, right?
Yep, I'm in Belize.
Ah, nice. Oh, although that's right. Your dad said you're not really going there for vacation, huh?
Well, it's
church
still
work or
fun.
Yeah, yeah, for sure.
Yeah.
It's going to be fun to go to Belize, yeah. Okay, so we don't have anything set up in the future. I'll just let your dad go ahead and schedule it. I do want to alert you to the fact that I'm going to be out of town from April 11th to April 15th.
Okay.
You might want to tell him that I'm out of town from the 11th through the 15th, and maybe you can schedule around it if you're looking for appointments during that. Okay, well, have a good spring break, and I'll probably talk to you when you get back, when you get done.
All right, thanks.
Okay, Max. Bye-bye.